Alright, here we are, Needle here, doing some precalc tonight. Um, so, here we are with a system of equations, and it says solve the system. So, what we're going to do, let's zoom in here. Okay, so you see here I've got x plus 2, I've got the answer to the right, just so, you know, we're going to solve this guy, 8, 10, 4. So, we've got this guy, x plus 2 over 6 minus y plus 1 over 3 plus z over 2 is equal to 0. So the first thing I'm going to do, this is just, really pesky. Sorry. The fractions here, they're just making life a lot harder than it needs to be. So I'm going to have x plus 2, and let me use a thinner, here we go, hopefully this works, x plus 2, oh, it's not as good. Alright, forget that. Alright, we have x plus 2, just make this thinner, over 6 minus the y plus 1 over 3 plus the z over 2 is equal to 0. And what I'm going to do is multiply all of this by 6. Okay? What I'm doing is clearing the fractions. So now I'm going to have x plus 2 minus the y plus 1 times 2 plus a z times 3. All of this is still equal to 0 because 0 times 6 doesn't change anything. Okay, I guess the larger font is actually necessary here. Okay, so now we're going to have x plus 2 minus a 2y minus 2. That's a minus. Plus 3z is equal to 0. Okay, this is almost set up. The plus 2 and the minus 2 cancel, so I have x minus 2y plus 3z is equal to 0. Okay, so that first equation over here, this guy, I've redone it. Okay, so let's just write that guy over there. This is going to be x minus 2y plus 3z is equal to 0. Okay, so that's the first equation. And I'm going to keep rewriting these equations because right now they're not in a good form to use. I wanted it to be in this form where I have some ax plus by plus cz, alright, is equal to 0. This is the form that I'm looking for. It's the one that I'm going to use to solve the system using a system of linear equations where you use the linear combination method. Okay, so all of this can go away if I'm actually on the right layer here. So let's get rid of let's do this correctly here. There we go, that's what I wanted. Okay, so that's all gone. Now to deal with the next one. Okay, it is x plus 1 over 2 plus y minus 1 over 2 is minus a z over 4 is equal to 8. Again, I'm going to do the same thing. The least common denominator here is 4, so everything gets multiplied by 4. So this is going to be 2 times an x plus 1 plus a 2 times y minus 1 minus az is equal to 32. Again, we're going to expand here, so 2x plus 2 plus 2y minus 2 minus z is equal to 32. And again, I'm just going to set everything, I don't have to set everything equal to 0. In fact, it makes, yeah, this should be a d, not necessarily equal to 0. It could be any number. So here we've got a plus 2 minus 2 again, so those cancel. And now I have 2x plus 2y minus z is equal to 32. Looks good to me. Okay, so we're going to put a 2x plus 2y minus z is equal to 32. Okay, again, I'm going to get rid of all of this stuff again. Moving on, last one. Then we have x minus 5 over 4. Let's see, plus a y plus 1 over 3 plus a z minus 2 over 2 is equal to 65 over 12. Okay, so here the least common denominator is 12. Everything gets multiplied by 12, so this is going to be a 3 times x minus 5, 4 times y plus 1, 6 times z minus 2 is equal to 65. Okay, just expanding here, 3x minus 15 plus 4y plus 4, it's a 4, plus 6z minus 12 equals 65. So the 3x plus 4y plus 6z is going to be on the left, and over here on the right I'm going to have 65 plus 12, so that goes away, and then minus 4, and then a plus 15. So 12 and 15 is 27. Added with the 65 should give me a 92. Minus 4 is an 88. Okay, so 3x plus 4y plus 6z is equal to 88. So we're going to write that over here. 3x plus 4y plus 6z is equal to 88. So now what we're going to do, again, I got to get rid of all this stuff. Delete that, and I'll just use the eraser for this part. Okay, so now I've got my 3 beautiful equations. They're right here. Let's bring them over. Use the lasso. Give me this stuff. Bring it over here. Ah, come on. There we go. Okay, so I've got these equations, right? What am I going to do with them? So I'm going to use the linear combination stuff. So if I were to remember these equations, 1, 2, I like the capital ones better, actually. Okay, so this guy's 1, this guy is 2, this guy is 3. I'm going to create 2 more equations, but see how these ones have 3 variables, x, y, z, x, y, z, x, y, z. I'm going to create 2 more equations that just have y's and z's, and then from there I'm going to create an equation that only has 1 variable, y or z. And honestly, the way that you pick these is up to you. You normally just want to pick the things that are easiest. So I mean, I'm looking at this, and if I add 1 plus 2, then I'm going to get x minus 2y plus 3z is equal to 0, and I'm going to add that to a 2x plus 2y minus z is equal to 32. Now why did I add these two? Because the 2y, the minus 2y and the plus 2y are just going to cancel, and I think it just makes it easy to work with. So this is 3y, these cancel to 0, plus 2z is equal to 32. Okay, so that's equation number 3 that I just created. So we'll get rid of this work. Bring this guy up. Up to there. Okay? Oh, wait. Oh, this is not equation 3, it's equation 4. Sorry about that. Okay? And I'm going to do the same thing. Now, since I used 1 and 3 before, or sorry, 1 and 2 before, I can't use that combination again. I can use 2 and 3, or I can use 1 and 3. I think it's easier to use 1 since there's a 0 here, so let's go ahead and use 1 and 3. I think that's easier. Then again, this just becomes 64. I don't know, I'll just do 1 and 3, it's not that big of a deal. Okay, however, if I'm going to have to delete the same, get rid of the same variable, so I need to get rid of the y's. So I've got x minus the 2y plus 3z is equal to 0, and I need to add that to a 3x plus 4y plus 6z is equal to 88. So you can see I need 2 times this amount, so I'm going to multiply everything by 2. That's going to give me a 2x minus 4y plus 6z is equal to 0. So I can get rid of that. So it's 2 times the, if I'm going to show what's going on here, it's 2 times equation number 1 plus equation number 3. That's what I'm doing right now. So when I add this up, that was terrible. Let's try to make a straight line. Come on, straight. There we go. Perfect. 5x, that's going to be 0, plus 12y, why 12y? 12z is equal to 88. Okay, this is equation number 5. So now, get rid of all this stuff again. Okay, so once you have your two equations, right, you see I've got two equations that just have x's and z's. Right, this is exactly what I wanted. So I think in this case it's easier to get rid of the z's because then I only have to multiply one equation instead of trying to get these guys to be a 15. So I'm going to go negative 6 times equation 4 plus equation 5, and that's what I'm going to do right now. So negative 6 times the first one is going to be a negative 18x minus 12z, and 32 times 6, I'm just going to use a calculator for this one. So 32 times a negative 6 is negative 192. Okay, and I'm going to add it to the other one. So 5x plus 12z is equal to 88. Add these guys up, so this is what we have, negative 13x. These get rid of each other. And then, let's see, so negative 192 plus 88 is equal to negative 104. If I divide both sides by 13, a negative 13, I get x is equal to 8. Okay? So just checking to make sure we got the first one right, that is correct. You can see here that the answer should be x equals 8, y equals, this is x, y, and z. So it should be x equals 8, y is equal to 10, and z is equal to 4. So we are on our way to getting the right answer. So there you go. We know x is equal to 8. So let's get rid of all of this. All of that work just to show that x is equal to 8, and we know that's the right answer. Once you have one of the variables, just go back to either equation 4 or 5 to figure out the next variable z. I think it's easiest to work with equation 4 here, so 3 times 8, I'm just plugging in whatever value I solve for x, plus 2z is equal to 32. So this is going to be 24 plus 2z is equal to 32, so I know that 2z is equal to 8, so z is equal to 4. Again, let's check our answer. Z is indeed 4. Great. So we're almost done. This is the home stretch. So we said x equals 8, z is equal to 4. So now we have to choose from either 1, 2, or 3. Let's just work with number 1. That's the easiest. So again, using the equation x minus 2y plus 3z is equal to 0. So that's going to be 8 minus 2y plus 3 times 4 is equal to 0. So that's going to be 8 minus 2y plus 12 is equal to 0. 2y is equal to 20. So y is equal to 10. Is that correct? Yes, it is. So there you go. Let's delete this. If you needed to ever look back at my work, just pause the video. And so we have y is equal to 10. So there you go. That's how you get your answer of 8, 10, 4. Again, if you need to see any of these steps, just go back and rewatch it. So that's the first problem. Now moving on to the second problem. Okay, so I need to work here. And I need to get rid of, oh wait, this is the answer for the next ones. It's these guys, 0, 13, negative 9, 4, and 9, 4. Okay, so this one says solve this system of equations by the method of choice. Let's see, what's the easiest way to do this? Well, this guy is a circle, and the reason I know he's a circle is because it follows this thing where it says x minus h squared plus y minus k squared is equal to 81. That's the form of a circle. So I know I'm dealing with a circle, and this guy is a parabola, and it is a y is equal to x squared. So this is a vertical parabola. So the question is, whenever you're trying to solve a system of equations, you're really looking for the intersection. Okay? For example, we just had 3 lines and they intersected at a certain point. That point was, what was it, 4, 10, or no, 8, 10, 4. Okay, so at that point. And if you have, let's just simplify the problem. If we have two lines, right? Okay, two lines. Here's one, and here's one, right? You can either intersect at one point, you can intersect at all points, where if you had like the line on itself again, or you can have parallel lines where they don't intersect at all. Alright, so we're looking for this case where they intersect. If there's no solution, that means that the circle and the parabola don't intersect each other at all. Now I'm just thinking as what's the best way to solve this one, and I think graphing might be the easiest, but I would just use a graphing calculator for that. Let's see. Other ways that you could do it, I don't know, like the thing where you the linear combination is really only good for lines. I mean, it's the easiest for that. So I think I will do it where I graph it. I think, or at least to start with. I think that's the easiest way to start this problem. Okay, so what does all this mean? This should be r squared, sorry. Let's erase that. The general form has it with r squared. The radius squared. Okay, so first let's find out the center of this circle. The center will be at, well, the first term, there's nothing here, so it's a 0. So the center of the circle is at 0, and this one is at 4. So 0, 4 is where I start. So 1, 2, 3, 4. Start right there. Okay, and I have a radius of 9. This number right here, 81, is the radius squared, so the square root of 81 is 9. So I'm going to go out in all directions 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Up here, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Down there. Okay. And can I draw a circle? I hope so. Using this tool here. Yeah, let's switch out the filling though. Fill color, none. Alright. No, that's the wrong one. Did I hold Alt? Yes. Okay, Alt Shift is the circle. Okay. So clearly my drawing was a little bit off. Okay, I don't really want to bother with it. It's a circle, okay? It's supposed to line up perfectly, but it doesn't. Okay, and the other one that we have is the x squared plus 9y is equal to 117. Now the general form for a parabola should be like this, right? Y is equal to some x squared. If anything, it's like ax squared plus b. So that's what I want to get to as well. Right, so this is going to be a 9y is equal to a negative x squared plus 117. And yeah, I guess I'll just divide everything by 9. So y is equal to 1/9, negative 1/9 x squared. And then 117 divided by 9. I don't know if it goes in evenly. No, it does. Plus 13. Okay, so this one's pretty easy to graph too. You just go up 13. So what was this? 4, 5, 6, 7. Oh, this is where it intersects. Oh, perfect, perfect. Right there. Okay, so this was at 4, right? Y equals 4, and then I had to go up 9 because this was my radius, right? So 4 plus 9 means that this point right here is 0, 13, and that's perfect because my y-intercept is at 13. Now this is a negative parabola, so it probably looks something like this. Okay? And since I know, I'm going to cheat a little bit, I know the answer, oh there you go. Yep, I intersect at 3 spots. Hey, that's almost perfect. Okay, so it's a negative parabola. I'm going to draw this a little better, so okay, so maybe it goes down like this. Okay, and alright, my spots of intersection are right here, and right here. Okay? So I don't know if graphing was the best way to do it, but if I were to do this problem without knowing the answer, I think I'd probably do graphing and realize that it intersects, or it has a chance to intersect at 3 different locations. And then I have to figure out, you know, where those occur. Yeah. So, let's back up. Okay. What I'm going to do is set these two equal to each other. Okay. And the way that we can do that is by setting both equations equal to 0, and if they're both equal to 0, then I can set them equal to each other, and then we're going to solve for all the different points. Okay, so this is go back to the red, I guess. Or we could try blue. Blue's a nice color. Okay, x squared plus y minus 4 squared is equal to, minus 81, because we're trying to make it equal to 0. Is equal to 0, and then I'll put this other one down here for now. X squared plus 9y minus 117 is equal to 0. So I'm going to set them both equal to each other. So let's get rid of this guy. Since they're both equal to 0, I can just, you know, set them equal to each other. There we go. I'll move that a little bit to the left. Okay. Now we're going to expand. So this is x squared plus, this is a y squared minus 8y plus 16 minus 81 minus x squared minus 9y minus plus 117 is equal to 0. Okay, so the x squareds cancel, it looks like. X squared and x squared cancel. Looks like the y squared stays there, so we say y squared. Yeah, so y squared, and then this is a minus 17y. And let's see, what happened to my x's? Oh, I only had one x. Okay. So let's back it up, and I'm gonna do this on the calculator again. So 16 plus, minus 16 minus 81 plus 117. Okay, so I get 52. Plus 52 is equal to 0. So let's try to factor this. Let's see, what goes into 52? And adds up to 17. Oh, Alright, let's just figure out what the factors of 52 are. So 52 is 26 times 2, which is 13. Okay, so it's 13 times 2 times 2. So 13 times 4, perfect, that's what I needed. So y minus 13, y minus 4 equal to 0, so we get y is equal to 13, and y is equal to 4. Okay, that's good, but we still need to figure out what these x's are. Okay? And I should have gotten... No, perfect. Y equals 13, y equals 4. That's all I needed. Okay, let's get rid of that. Now, as far as the next equation to use, let's see. I don't think it matters which one you use, so let's just go ahead and use the parabola. I think it's easier that way. What I found right in here, what do these mean? What is this y equals 13, y equals 4? By setting these two equations equal to each other and searching for and finding out, okay, so I set the two equations equal to each other because if I do that, whatever I find will be where they intersect. Okay, they could be the x values or the y values. It just so happens that the x values canceled out, okay, which left me with only y values. So now I know that the parabola and the circle intersect at 13 and at 4, and I know that's right because I can see here that the y values are 13, 4, and 4, so I know that's right. And so what am I going to do now? Well, I'm going to use the parabola now, okay, knowing that they intersect at y equals 13 and y equals 4. Okay, so I'm going to say x squared plus 9y is equal to 117, and I'm just going to be solving for x here. Again, I should get 3 different answers. So if I'm going to say x squared is equal to 117 minus 9y. Okay, so let's see. right. For the first one, I'll have x squared is equal to 117 minus 9 times 13. Okay, 9 times 13. 9 times 13 is equal to 117. Perfect, so I get x squared is equal to 117 minus 117. X squared equal to 0. Let me just scroll down here. So that means that x is equal to 0. Okay, so that's my first point. 0, 13. When x is equal to 0 and y is equal, when x is equal to 0, y equal to 13. I'm going to do the same thing again, but instead of 13, I'm just going to plug in my 4. Okay, so we'll say x squared is equal to 117 minus 9 times 4. So that's 117 minus 36. Again, just going to use calculator here, save some time. Okay, I get 81. X squared is equal to 81. So when you take the square root of that, you're going to get x is equal to plus or minus the square root of 81. So that's going to be x is equal to plus or minus, wow, almost fooled you guys, right? 9. Okay, x is equal to plus or minus 9. So those coordinate points are going to be 9 and 4, and then the other one, which is 9, negative 4. So those are your answers. That's where they intersect. So I guess this guy is actually, okay, this should be higher actually, right? So 9, 4 is actually right there because it was 4 high. So it intersects right there. These guys right here. Here, here, and there. Okay, so again, the graph didn't like tell me exactly where it was going to be, but because I drew the graph first, I had some idea of, what the answer was going to look like. I knew I was dealing with the vertical parabola, and a negative one at that. And the way that you know that it's negative is because when I subtracted over the x squared, right, I got 9y is equal to a negative x squared. A negative x squared means that you're going to have a parabola that's going down like this. And again, whenever you see an x squared plus a y squared, you should be thinking a circle or ellipse, right? Ellipse will have a some fractions down here, like over a, and then this one over b. Okay? But whenever you see that x squared plus y squared equaling something else, that you should be thinking automatically a circle. Okay, so there you have it, right? The answers were 0, 13, negative 9, 4, and 9, 4. I hope this video helped. Again, if there's any part that you don't understand, go back to the video, just replay it as many times as you need to. And also, it's okay to, look at all this stuff and, see how to do the solution, but I highly recommend that you go back, refresh the page. You're going to get new problems, right? With the same problem, but different numbers. So it's really important to understand, break down these problems, how do I do it, but then to go back and practice on your own. Okay? In a test situation, you don't get any help, right? Everything you have to do on your own. So, really, if you prepare enough for the test, you will be fine. Just do enough problems until the math becomes easy. Again, these types of problems, I could have skipped the whole graphing thing and just set them equal to each other, and I would have been able to find the right answer. And also, on the first problem, this is just solving using linear equations, and nothing really changes here. I mean, this is a set procedure. Clearing the fractions was a little different. Normally problems won't have that, but the thing where you take your 3 equations and use linear combination to eliminate variables, take those new equations and eliminate another variable, go back, plug in, and solve. That is all the same. It will never change. All they can change are the numbers. So get this method down. Again, it's called, so the whole thing is called systems of linear equations, right? Systems of linear equations. And the method that I have here is called linear combination. There are other methods like the substitution method, but the linear combination method I think is faster if you have like easy whole numbers. If you don't, sometimes substitution is better. Anyway, I hope this video helps. Make sure to leave a like and a favorite. Helps out the page. And good luck.